Hello students and good morning. So now I am doing class for class 12 science. In the last online class we finished standard integrals. So today we will start the new chapter, that is integration by parts. Okay, so this is from the integration chapter. So what is meant by integration by parts? So what is the method? What is the method for integration by parts? So today we will discuss this chapter, integration by parts. Okay. So when do we use integration by parts? Suppose there is integration of the product of two functions, then we can use integration by parts. Okay. Suppose we have I is equal to integration of u v dx. Suppose there is integration of u into v dx, where u and v are two different functions of x. Where u and v are two different functions of x. Okay. Suppose there is integration of u into v dx. Suppose there is integration of the product of two different functions of x. Then we have to use integration by parts. So in this case, integral sign u v dx. These u and v are two different functions of x. So this u may be logarithmic function, b may be exponential function, u may be trigonometric function, b may be inverse circular function, u may be logarithmic function, b may be trigonometric function, and so on. Okay, u may be algebraic function, b may be exponential function. So you know that there are 5 types of functions. So I already told you about the word liet, or it may be islet. Okay, so what is I here? I means inverse circular function, I means inverse circular function, or it may be inverse trigonometric function. Okay, what is L? What is L? It is logarithmic function, logarithmic. This is logarithmic function. A means algebraic function. A means algebraic function. Okay. T means trigonometric function. T means trigonometric function. Okay. And what is E? E means exponential function. E means exponential function. So I had already told you about this liet or islet. Okay, so here I means inverse circular function, L means logarithmic function, A means algebraic function, T means trigonometric function, and E means exponential function. Okay, so where u and v are two different functions of x, these functions may be inverse circular function, logarithmic function, algebraic function, trigonometric function, or it may be exponential function. Okay, so now what is the method of using integration by parts? So what is the formula now? So there is a formula for this integration by parts. Okay, so let us write down the formula for integration by parts, and after that I will derive that formula. Okay, so in this case there is integration of u v dx. So you must know which is the first function and which is the second function. Suppose in this case u is the first function and v is the second function. So by integration by parts we can write, there is a formula. Therefore I is equal to, I told you that suppose u is the first function and v is the second function. So what is the integration by parts here? So u is taken outside. This first function, u is the first function and v is the second function. Now the first function is taken outside integral sign. Okay, u integral sign v dx, u integral sign, this is v dx, then write minus. Integral sign, then second bracket. You have to take the differentiation of the first function with respect to x, that is dy dx of u, okay, then again integration of, that is second function v dx. This second bracket is closed, and for this integration you have to write dx. Is that clear? Suppose there is integration of the product of two different functions u v dx. So in this case you should know which is the first function and which is the second function. Suppose in this case u is the first function and v is the second function. So the first function is taken outside integral sign, that is u integral sign v dx, then minus integration of, that is you have to take the differentiation of the first function with respect to x, then again integrate the second function with respect to x. This second bracket is closed, and for this integration there is dx. So this is the formula for integration by parts. You should know it. Okay. So we can write here actually I is equal to, what is u here? U is the first function. Actually you have to remember this formula, right? This is very, very important. This is integration by parts formula, right? So now I is equal to u is the first function into integration of the second function, right? First function into integration of the second function minus integration of within bracket dy dx of u means differentiation of the first function, of the first function into what? V. V is the second function. That is the integration of the second function. That is, you have to write integration of the second function. So this is the formula, right? So I is equal to u integral sign v dx minus integral sign differentiation of the first function with respect to x, then integration of the second function, second bracket closed, then for this integration you have to write down dx. So this is known as integration by parts, okay? Or I is equal to u is the first function into v dx, integration of v dx means integration of the second function minus this integration of within bracket differentiation of the first function into integration of the second function. So that is the formula. So I think you have understood it, so you can copy it. Now I'll derive this formula, okay? So now let us derive it. So you can copy it. So now we will derive this formula now, okay? Now proof of this formula. So now let us do its proof. Now proof of formula for integration by parts, okay? So now you know the differentiation of the product of two functions, that is your product rule. You have done it in class 11 also, right? Suppose you have dy dx of u into, let us write w here, where u and w are two different functions of x. So how can you find out the differentiation of the product of two different functions with respect to x? You know that this is known as the product rule. So you know the differentiation of the product of the two different functions, isn't it? So is equal to u into differentiation of the second function, u is kept as it is, plus now w is kept as it is, into take the differentiation of the first function with respect to x. Okay, you know this differentiation, isn't it? That is the differentiation of the product of two different functions with respect to x. That is known as the product rule. Okay, now let us cross multiply by dx, or d of uw is equal to this is u into dw by dx into dx plus w into du by dx into dx. Is that clear? Now it is cross multiplied by dx, but in this case you cannot cancel this dx. Don't cancel it. You cannot cancel it. Okay, so now you know that dx, if there is only dx, you can write integral sign before that, isn't it? So this is just like your dx, isn't it? Instead of x there is uw. x को जग्गामा चाहिँ यहाँ के छ uw छ. It is just like your dx. यसको जोडी चाहिँ के हुन्छ? You have to write integration sign. Similarly, for this dx, u and dw by dx are the variables, so you can write here integral sign. So here also for this dx, w and du by dx are also the functions of x, that is the variable. You have to write down integration sign. So I think you have understood it. Okay, now in this case, if you have integral sign dx, then we can write only x in this case, isn't it? But if you have instead of x there is uw, what is integration of differential of uw? That is integration of dx is x. What is integration of d of uw? It is uw. It is uw is equal to, now in this case this right hand side is kept as it is, that is integration of u into dw by dx into dx, right? Next plus integration of w into du by dx into dx. So I think you have understood it. Okay, now in this case let us assume this dw by dx as v. Okay, that is actually we had written integral sign uv dx, isn't it, where u is the first function and v is the second function that in that case. So let us assume this dw by dx as v. Let v is equal to dw by dx. Let v is equal to dw by dx. Let us assume this dw by dx as v. So let us do cross multiply, or b ko talo 1 cha, below v there is 1. Now let us cross multiply. dw is equal to v dx. So you can use integral sign now. Both sides. V is the variable. So before v you can write integral sign. What is integral sign dw? It is w, because integral sign dx is x. Similarly, what is integral sign dw? That is w is equal to integration of v dx. Is it clear now? So now in this case, wherever there is dw by dx you have to write v, and wherever there is w you have to write integral sign v dx. Is that clear now? So now this equation now becomes, therefore we can write here u is kept as it is. What is w? It is integration of v dx, right, is equal to, now this becomes integral sign u into, what is dw by dx? It is v. It is v dx plus integral sign. Let us write first du by dx. It is du by dx. Is that clear? Let us first write du by dx. What is w now? Here w is integration of v dx. Integration of v dx. For this integration dx is there. For this integration you have to write dx here. So keep it within second bracket. So here we have dx. Is that clear? So this integral sign is there. Then we can write du by dx. Okay. So we are putting these values out here. That is u instead of w. Instead of u is kept as it is, isn't it? U is kept as it is. What is w? it is integration of v dx is equal to integral sign u into what is dw by dx? It is v. This is v, isn't it? dw by dx is v. So dw by dx is v dx plus integral sign. First you write du by dx. Then what is w? W is integration of v dx. It is kept within second bracket. Then we can write dx out there. Is that clear now? So in the next step, now let us write or. So let us take this second term to the left hand side. So it will be u integral sign v dx minus, right? This plus becomes minus on the left hand side. Then integral sign second bracket, this is d by dx of u. Let us write du by dx as d by dx of first function u. That is integration of, then we can write v dx, second bracket close, dx, which is equal to, what is there on the right hand side? It is integral sign u v dx. Integral sign u v dx. That means we have derived the formula for integration of the product of two different functions, that is u v dx, which is equal to, here u is the first function and v is the second function. So u is taken outside, integral sign u integral sign v dx minus integral sign second bracket d by dx of the first function, then integration of the second function with respect to x, second bracket is closed, dx. अब हामी के गर्छौं? Now यो जुन चाहिँ राइट ह्यान्ड साइडमा छ टर्म, यसलाई लेफ्ट साइडमा लेख्छौं अनि यो लेफ्ट साइडको सबै टर्म हामी कता लेख्छौं? राइट ह्यान्ड साइडमा लेख्छौं. So in that case you don't have to change the sign. So or let us write this right hand side on the left hand side. So it is integral sign u v dx. अब यो लेफ्ट साइडको सबै हामी कता लेख्छौं? राइट ह्यान्ड साइडमा लेख्छौं. So it is u integral sign v dx minus integral sign second bracket d by dx of u integral sign v dx second bracket closed, then you can write dx. So this is the formula for integration by parts. So you should know this formula, right? So this derivation, you may not get this derivation in your examination, but you should have the knowledge of this derivation, but you should know this formula. Okay, that is, what is integration of the product of two different functions u v dx, which is equal to, suppose here u is the first function and v is the second function. So first function is taken outside, u integral sign v dx minus integral sign differentiation of the first function with respect to x into integration of the second function with respect to x, second bracket is closed, and for this integration you have to write down dx. So this is the rule of integration by parts. So I think you have understood this derivation, so you can copy it. Now I'll show you some examples regarding this integration by parts. So you can copy it. So now let us do some examples regarding integration by parts. So this problem is the application of integration by parts. So how can you integrate this function using integration by parts? So here this is integration of the product of two different functions, that is x sec square x dx. Okay, so let us write here I is equal to integration of, this is x sec square x dx. Okay, now first of all, in this case you should know which is the first function and which is the second function, and for this you should know this word liet. I already told you about liet, or it may be islet also. In order to know which is the first function and which is the second function, you should know these two words. It may be liat, liet, or it may be islet. Okay, so you know the meaning of this ILAT. I means inverse circular function, L means logarithmic function, A means algebraic function, T is trigonometric, and E is exponential. Is that clear? What is I? Inverse circular function. What is L? Logarithmic function. A, algebraic function. T is trigonometric function, and E is exponential function. So you should know this function now. What is x? X is an algebraic function. x is an algebraic function, that is a. Sec square x is a trigonometric function. And which letter comes first here? X is algebraic function, that is a. Sec square x is a trigonometric function, that is t. Which letter comes first in the word islet or liet? A comes first, isn't it? Among these a and t, in this word islet or liet, a comes first. So this a is the first function. That is, x is the first function and sec square x is the second function. So now we can easily use integration by parts. Okay? Or I is equal to, which is u here, which is the first function, x, it is taken outside. Integration of what is v, which is the second function, it is sec square x dx. Then you should write down minus sign. Then integral sign, second bracket. Take the differentiation of the first function with respect to x, that is dy dx of x, integral sign, then what do we write? Then second function, that is your sec square x dx, second bracket is closed, and for this integration you have to write down here dx. So this is the rule of or formula for integration by parts. Okay, so now we can use the method as we have done, as we were doing in the previous chapter. Okay, so now we can easily integrate them. So or I is equal to x into, what is the integration of sec square x? That is differentiation of which function is sec square x? That is your tan x. Okay, minus integral sign. What is dy dx of x? That is your 1. You don't have to write it. Again, what is integration of sec square x dx? That is your tan x dx. So I think you have understood it. Okay, or this is I is equal to x tan x minus, now you should know this integration of tan x dx. So we have done it in the method of substitution. So what is integration of tan x? It is log within mod sec x mod sign close, the base is e, then what do we write? Plus c. So this is the final answer. So I think you have understood it. So this is quite easier, isn't it? So you should know the rule of integration by parts, and then we can use the integration as we were doing in the previous chapters. Is that clear? So integration of tan x dx is log of sec x. You may write, what is integration of tan x dx? There is another formula, that is, what is integration of tan x dx? Which is equal to minus log within mod cos x base e. That also you can write it here. Or you may write log of sec x base e plus c. Okay, so you can copy it. Now I'll show you another example. So you can copy it. Now I'll show you another example of integration by parts. So let's do another example. So now example number 2, right? So let's do example number 2 now. So I'll show you example number 2 next. Example number 2, that is integration of x e to the power x dx. So this is also the integration of the product of two different functions. One is x and the other one is e to the power x. Okay, so which is the first function or which is the second function? You should know this word. Either you can use liet or islet. Okay, you can use either liet or islet. Kuनै एउटा युज गर्नु, liet use गर्दा पनि हुन्छ, islet use गर्दा पनि हुन्छ. So let us first write, we are integrating it. So I is equal to integration of x e to the power x dx. Okay. Now this is also the integration of the product of two different functions. One is x and the other one is e to the power x. What is x here? X is an algebraic function, that is a. And e to the power x, you know that it is the exponential function. Okay. So this is a and this is e. Which letter comes first in the word islet or liet? A. A comes first, isn't it? So this algebraic function x is the first function and e to the power x is the second function. Now we know which is the first function and which is the second function. So in this case, x is the first function and e to the power x is the second function according to this word islet or liet. Okay, so again, x is the algebraic function, you know that. E to the power x is the exponential function. So which letter comes first in the word islet or liet? That is a comes first. That is your algebraic function. So this x is the first function and e to the power x is the second function. So let us use integration by parts now. So x is the first function, x is taken outside, integral sign e to the power x dx minus integral sign second bracket. This is d by dx of x, integral sign e to the power x dx second bracket closed dx. Is that understood now? So this is the rule of integration by parts, or this is the formula for integration by parts. Okay, so or I is equal to x into, what is integration of e to the power x dx? You know the formula. Differentiation of which function is e to the power x? This is your e to the power x minus integral sign. What is d by dx of x? That is 1. You don't have to write it. What is integral sign e to the power x dx? That is your e to the power x dx. Okay. So or I is equal to, this is x e to the power x minus, what is integration of e to the power x dx? That is differentiation of which function is e to the power x? That is your e to the power x. Then what do we write? Plus c. So this is the final answer. So now I think you have understood it. So now let's do more problems from the book. So now we will do problems from the book, that is integration by parts, exercise 7, page number 380. 2 mark section from the book Higher Mathematics for Class 12 by Sailendra. So let us integrate this function with respect to x. That is question number 1. That is, you have to integrate integral of log x dx. Let us first write I is equal to integration of, this is log x dx. So what is integration of log x dx? We haven't done it. This is in integration by parts chapter. So this is integration of only log x is there. So if there is only log x, also in this case you have to use integration by parts. Actually there are two functions here, log x and 1. So 1 can be taken as x to the power 0. So actually this is log x into 1. So if there is integration of only log x, that is logarithmic function, you have to use integration by parts in this case. Actually, you should know that there are two functions here, log x and 1. And 1 can be written as x to the power 0. Or it may be e to the power 0. It may be x to the power 0 or e to the power 0. So this function is taken as algebraic function or exponential function. It may be taken as algebraic function or exponential function. So actually it is log x multiplied by 1. So 1 can be taken as algebraic function or exponential function. Okay, so in the word liet or islet, suppose if you write islet, let us write islet, you may write liet also. This log x is this logarithmic function, this and x to the power 0, 1 is there, 1 is x to the power 0. It may be a algebraic function or it may be exponential function. That is, L comes first. In this case, logarithmic function comes first. That is, L comes first in the word liet. So logarithmic function is the first function, and x to the power 0, it may be either algebraic function or exponential function. So it is the second function. So 1 can be taken as algebraic function or exponential function. So it is the second function. So which is the first function in this case? Log x, logarithmic function is the first function in this case. Now we can use integration by parts. So therefore I is equal to, this log x is taken outside, log x integral sign, then what do we write? Dx minus integral sign second bracket, take the differentiation of the first function with respect to x, that is log x is the first function, right? D by dx of log x integral sign, then what do we write? dx, second bracket closed, dx. So I hope you have understood it. Okay, so or I is equal to, let us first integrate. What is integral sine dx? That is your x. Then what do you write? Log x. Then comes minus integral sine, what is d by dx of log x? You know the differentiation of log x with respect to x. What is it? 1 upon x into what is integral sine dx? That is your x. Then what do we write? Dx. Here x gets cancels. So or I is equal to, this is x log x minus integral sine, this is dx. Okay, so or I is equal to, this is your x log x minus this is x, integral sine dx is x. Then what do we write? Plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 6, and these are your homework. Okay, question number 2, integral sine x cos x dx. You can use integration by parts. You should know which is the first function and the second function. Use liet or ilet word to know which is the first function and which is the second function. Similarly, you can do this number 3, integral sine x e to the power x dx. Question number 4, integral sine x sine x dx. And question number 5, integral sine x sec square x dx. So all these are your homework. That is question number 2, 3, 4 and 5. So let's do this question number 6. That is integration of, this is sine inverse x dx. So let us first write I is equal to integral sine inverse x dx. So we haven't done integration of inverse circular function. So here also this is integration of only one function. That is only inverse circular function is there. Here also you have to use integration by parts. Actually there are two functions there. One is sine inverse x and the other one is 1. One can be written as x to the power 0 or e to the power 0, isn't it? Or x to the power 0. So this x to the power 0 may be taken as, I already told you that this x to the power 0 can be taken as exponential function or algebraic function. So this is your sine inverse x is the inverse circular function, and in the word liet or ilet, this I comes first, isn't it? That is in case of ilet or liet word. So you know that sine inverse x is an inverse circular function, and 1, that is x to the power 0 or e to the power 0, it may be taken as algebraic function or it may be taken as exponential function. That is, this sine inverse x is I and x to the power 0 is a. So sine inverse x, that is inverse circular function, I comes first in the word liet or ilet, isn't it? So this sine inverse x will be the first function and 1 is the second function. So you can use integration by parts. So let us use integration by parts here. So I is equal to, now this sine inverse x is the first function, you can take it outside. So this is sine inverse x integral sine dx. Then comes minus sine integral sine second bracket open d by dx of the first function. Which is the first function in this case? Sine inverse x, right? This is sine inverse x integral sine, then what do we write? Dx second bracket closed dx. Is that understood now? So let us simplify it. Or I is equal to, now let us integrate dx first. What is integral sine dx? That is your x, you know that, x, then comes sine inverse x minus integral sine, what is d by dx of sine inverse x? It is 1 upon root over 1 minus x square. You know the differentiation of sine inverse x, isn't it? It is 1 upon root over 1 minus x square into what is integral sine dx? That is your x dx. Okay, so integral sine dx is x and you have to write down this dx. Or now this is I is equal to x sine inverse x minus, let us write it as I1. Okay, that is integral sine 1 into x is x divided by root over 1 minus x square is there, then dx. So let us find out the value for I1 now. Let I1 is equal to integral sine, this is x dx divided by root over, this is 1 minus x square. Okay, so now let us integrate it. So how can you integrate it? You have to use method of substitution in this case, because what is the differentiation of 1 minus x square? That is minus 2x, but we are getting x, isn't it? So we can assume this 1 minus x square as z, but 1 minus x square, this expression is under square root, and the square root is in the denominator. Whenever the square root is in the denominator, you have to assume that 1 minus x square as z square. I already told you about that, this one, isn't it? So let us assume 1 minus x square as z square, isn't it? Because the expression is under square root and the square root is in the denominator. So we can assume the expression 1 minus x square as z square. Okay, so let z square is equal to 1 minus x square. So let us differentiate it. So differentiating both the sides, with respect to x. So what is the differentiation of z square with respect to x? What is it? It is 2z. It is 2z into dz by dx is equal to, for 1 it is 0, for minus x square it is minus 2x. Is that clear? So you can cancel these two, cancel them. Now let us do cross multiplication. So z dz is equal to minus x dx. So I think you have understood it. Okay, now let us get the value for x dx only. Minus sign is taken to the left hand side. So it is minus z dz is equal to, this is x dx. So I think you have understood it. Okay, so let us put these values in I1. So what is I1 now? So therefore I1 is equal to, what is it? Integral sign, this is integration of what is x dx? It is minus z dz, right? So you have to write minus z dz in this case, divided by, now in the denominator it will be root over z square, isn't it? What is root over z square? It is z. Is that clear? So now we can cancel this, z will be cancelled, cancel it. Or I1 is equal to, minus sign is taken outside, integral sign dz, or I1 is equal to, this is minus z plus c. What is integral sign dz? That is your z. So it is minus sign, minus z plus c. Now put the value for z. Or I1 is equal to minus, what is the value for z? Actually z square is equal to 1 minus x square. So what is the value for z? It is root over 1 minus x square. So it is root over 1 minus x square, then plus c. So but this is not the answer. This I1 is not the answer. So you have to put these values of I1 in I. So what is I actually? It is I is equal to x sine inverse x minus I1. So in this case you have to put the value for I1. So let us write, since I is equal to, this is x sine inverse x minus I1. Is that clear? So let us put this value for I1 now. So what does it become? Or I is equal to x sine inverse x, then this minus to minus is plus sign, root over 1 minus x square plus c. So this is the final answer. So I think you have understood it. So you can copy it. So these are your homework number 2, 3, 4, 5. You can do it at home. Okay. So let's do the next question now. So now we'll do the next question, that is question number 10. So these are your homework again, that is question number 7, integral sine cot inverse x dx. I will not give you the hint, you have to do it yourself. Okay. Question number 8, integral sine sec inverse x dx. And question number 9, integral sine cosec inverse x dx. So these numbers 7, 8 and 9 are your homework. Okay. So let's do this question number 10 here. So you have to evaluate this integration, that is integral sine cos inverse within bracket 1 upon x dx. So if there is cos inverse 1 upon x dx, how can we simplify it? We can write it in terms of sec inverse x. What is cos inverse 1 upon x? It is sec inverse x. What is cosec inverse 1 upon x? It is sine inverse x. So similarly, what is cos inverse 1 upon x? You know that cos and sec are opposite function. So in order to take this x to the denominator, so while taking x to the denominator, you should write here sec inverse x. That is, what is the formula for cos inverse 1 upon x? It is sec inverse x. So here we can write I is equal to integration of, this is sec inverse x dx. It is same as problem number 8 now. So this is also one of the function, only one function is there, but this is inverse circular function. So if there is only one function, that is inverse circular function, then also you have to do it by integration by parts. You have to integrate it by parts. So there are two functions actually. So if there is integration of only logarithmic function, you have to do integration by parts. If there is integration of only inverse circular function, here also you have to do integration by parts. So actually there are two functions here. One is sec inverse x and the other one is 1, which can be taken as x to the power 0. That is your algebraic function, or it may be exponential function. Okay. So now this sec inverse x into 1. So according to the what Eilert or Liet, this is I, inverse circular function comes first. That is, the letter I comes first. Then after that, algebraic function will come. In the word Liet or Eilert, I comes first, then a or exponential function will come, isn't it? So this I, that is sec inverse x, will be your first function. You know that, isn't it? So therefore, let us use integration by parts here. I is equal to, this is the first function. It is taken outside, that is the value for u, sec inverse x, integral sine. Then what do we write? Dx minus integral sine, second bracket, take the differentiation of the first function with respect to x. That is your d by dx of, this is sec inverse x, right? Then you have to write integral sine dx, second bracket closed, dx. So I think you have understood it. So this is the rule of integration by parts. So I think you know it, isn't it? So let us simplify it. Therefore I is equal to, what is integral sine dx? That is your x. Let us first integrate. So what is integral sine dx? That is your x. Now sec inverse x is kept as it is. That is your sec inverse x minus integral sine. What is d by dx of sec inverse x? You should know it. What is the differentiation of sec inverse x? It is 1 upon x root over x square minus 1. Okay? Into, what is integral sine dx? That is your x dx. So here you can cancel this x, cancel them. So or I is equal to, this is x sec inverse x minus integral sine, this is dx divided by root over, this is your x square minus 1 can be written as 1 square, right? So in this case 1 can be written as 1 square. Okay. So why am I writing 1 as 1 square? If you can convert this 1 into 1 square, then this is the standard integral. That is, we have done it in a standard integral. There are 6 standard integral, isn't it? So this is the 5th standard integration. That is, you can use integral sine dx divided by root over, this is x square minus x square. So you should know this standard integral, that is standard integral number 5. So you can go through this standard integral and you can check it. Okay. So what is integral sine dx divided by root over x square minus a square, which is equal to log within mod x plus root over x square minus a square, mod sign closed, base e plus c. Okay. So let us write it here now. I is equal to, this is your x sec inverse x minus, what is the formula in this case? This is the fifth standard form. Log within mod, the base is e. What is x out here? It is x plus root over, what is x square minus a square here? X square minus 1 square is 1, mod sign closed, plus c. So this is the final answer. So I think you have understood it. Okay, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 11. You have to evaluate this integration. The question is integration of x to the power n log x dx. So let us write it first as I is equal to integration of x to the power n into log x dx. Okay. Now this is the integration of the product of two different functions with respect to x. So you have to use integration by parts. So first of all, you should know which is the first function and which is the second function. So I already told you about the word liet or islet. You may use liet or you may use islet also, isn't it? So what is x to the power n? It is an algebraic function. And what is log x? It is a logarithmic function. So L and A are there. One is logarithmic function and the other one is algebraic function, L and A. So which letter comes first in the word liet or islet? That is L. L letter comes first, isn't it? In the word liet or islet. That is, one is islet and the other one is liet. So in this case, we have x to the power n is algebraic function and log x is logarithmic function, L and A. So which letter comes first in the word liet or islet? L comes first, that is logarithmic function comes first. Okay, so log x is the first function and x to the power n is the second function. Is that clear? So let us use integration by parts here. So which is the first function here? Log x. It is taken outside, integral sign x to the power n dx. The बीच में क्या sign है? Minus integral sign, then dy dx of the first function, that is your log x. Log x, integration of x to the power n dx, second bracket closed. Then what do we write? Dx. So I think you have understood it. You have used this. You know what is integration by parts and you should know this formula also. Okay. So or now I is, let us first integrate x to the power n. So you know what is integration of x to the power n? It is x to the power n plus 1 divided by n plus 1 into what? Log x minus integral sign. What is dy dx of log x? 1 upon x into what is integration of x to the power n? X to the power n plus 1 divided by n plus 1. Then what do we write? Dx. So I think you have understood it. Okay. Or I is equal to, first term is x to the power n plus 1 into log x divided by n plus 1, right? Minus sign then. Then which is the constant here that you can take outside? Which is the constant term here? 1 upon n plus 1, that is constant, it is taken outside. Integration 1 upon n plus 1 integration of. Now both are the variables here, x to the power n plus 1 divided by this is x to the power 1. So when this x to the power 1 goes up in the numerator, you can simplify it with x to the power n plus 1, isn't it? That is x to the power n plus 1, then this becomes minus 1. Then what do you write? Dx. So here this 1 gets cancels, you know that. So or I is equal to, this is x to the power n plus 1 into log x divided by this is your n plus 1 minus this is your 1 upon n plus 1 integration of this is x to the power n dx. So I think you have understood it. Okay. Now again you can integrate x to the power n dx. That is your last integration, right? So therefore I is equal to, this is x to the power n plus 1 into log x divided by, this is your n plus 1 minus 1 upon n plus 1 minus 1 upon n plus 1 into, what is integration of x to the power n? It is x to the power n plus 1 divided by n plus 1 plus c. Is that understood now? So we can take common here, or I is equal to, what is common here? X to the power n plus 1 divided by n plus 1 is taken common. So within bracket, what do we have? We have, this is log x minus this x to the power n plus 1 divided by n plus 1 is taken common. So we have only 1 upon, this is n plus 1, third bracket closed, plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 12. You have to evaluate this integration. The question is, you have to integrate x sine inverse x dx. This is also the product of two different functions. So in this case also you have to use integration by parts. So let us write it first as I is equal to integration of x sine inverse x dx. Okay. So now in this case you should know which is the first function and which is the second function, because this is the integration of the product of two different functions. So here x is an algebraic function a, sine inverse x is the inverse circular function, that is I. So which letter comes first in the word liet or ilet? That is I. Inverse circular function comes first, that is I comes first. So this sine inverse x will be your first function, sine inverse x will be your first function, and x is the second function. So let us use integration by parts now. So I is equal to sine inverse x integration of x dx minus integration of second bracket dy dx of the first function, that is your sine inverse x, again integration of the second function, that is integration of x dx, second bracket closed, then you should write dx. Is that understood now? So let us integrate it now. So or I is equal, let us first integrate x dx. What is it? It is x square by 2, this is your sine inverse x, minus integration of, what is the differentiation of sine inverse x with respect to x? You know that, isn't it? That is 1 upon root over 1 minus x square into again, what is integration of x dx? That is your x square by 2 dx. Understood? So or now this is I is equal to, this is x square by 2 sine inverse x minus integration of, sorry, this is half is taken outside now here. So this is half is taken outside, integration of x square divided by root over 1 minus x square dx. Is that understood now? So let us assume it as I1. Okay. So or I is equal to, this is x square by 2 sine inverse x minus, suppose this is I1. So let us write, let, what is I1 here? I1 is equal to half integration of x square divided by root over 1 minus x square dx. So how can you evaluate this I1? How can you evaluate this integration? So in this case we have x square in the numerator and root over 1 minus x square in the denominator. So in this case you have to consider the expression on the square root, that is 1 minus x square. So in this case you can do the method of substitution, that is method of substitution by trigonometric function. So we can do trigonometric substitution method in this case. So within square root we have 1 minus x square. So what should be the value for x? I already told you about this one, isn't it? If there is root over 1 minus x square, you should put x is equal to sine theta. If there is root over 1 plus x square, you should put x is equal to tan theta. If you have root over x square minus 1, you should put x is equal to sec theta. I already told you about that one. You can check the previous classes. Okay. So now let us assume here, let x is equal to what? Sine theta. Let us put x is equal to sine theta. Now what will you do now? Differentiating both the sides with respect to theta. So what do we get? Dx by d theta is equal to, what is differentiation of sine theta with respect to theta? That is your cos theta. Now let us do cross multiplication. What is dx is equal to? This is your cos theta d theta. So I think you have understood it. Okay. So let us put these values in I1. So what is I1 now? So I1 is equal to half is already there. Half is already there. Integral sign. What is x square? It is sine square theta. X square is sine square theta. What is dx? It is cos theta d theta divided by root over. It is 1 minus sine square theta. It is 1 minus sine square theta. Is that clear now? So now let us simplify it before integration. Okay. So within square root 1 minus sine square theta, what is the formula? It is cos theta, right? So I1 is equal to half integration of, this is your sine square theta cos theta d theta divided by, this is your cos theta. So here cos theta gets cancels. So or I1 is equal to, this is half integration of sine square theta d theta. So I think you have understood it. Okay. So now you know the method how to integrate sine square theta d theta. So I already told you about this. If there is integration of sine square theta or cos square theta, you have to convert it into multiple angles form. That is, you have to use the formula of 2 sine square theta or 2 cos square theta. But there is no 2 out here. So you should multiply and divide by 2 to make it 2 sine square theta, right? So let us multiply and divide it by 2. So what do we get? 1/4 integration of, this is 2 sine square theta d theta. Is that clear? So what is the formula for 2 sine square theta? You know that 1 minus cos 2 theta. Okay. So or I1 is equal to, this is 1/4 integration of, this is 1 minus cos 2 theta bracket close d theta. Now you can separate this integration and then you can easily integrate them. Or what is I1 now? So or I1 is equal to, let us separate the term. 1/4 integral sine d theta. It is 1/4 integral sine d theta. Then minus sign is there, minus 1/4. Again it is multiplied by 1/4 integral sine cos 2 theta. Integral sine cos 2 theta d theta. Is that clear to all of you? So you have understood it. So let us integrate it. So I1 is equal to 1/4. What is integral sine d theta? That is your theta. 1/4 into, now what is integration of cos 2 theta d theta? Or differentiation of which function with respect to theta is cos 2 theta? So it will be sine 2 theta divided by 2 plus c. Okay. So now in this case again you have to simplify it. You have to write down the answer in terms of x. But actually what was theta? What was theta? If there is only theta, you have to write it in terms of inverse circular function. So from here, what is theta? It is sine inverse x. Okay. So let us write it here. I1 is equal to, this is 1/4 sine inverse x minus 1/8 into, but in this case sine 2 theta is there, so you can't put the value for theta in this case. That is not your simplified form. Okay. So let us simplify it. What is sine 2 theta formula from multiple angles? it is 2 sine theta cos theta. Then what do we write? Plus c. Okay, so 2 1s are 2, 2 4s are 8. Or this is your I1 is equal to 1/4 sine inverse x minus 1/4. Is that clear? That is only 1/4. What is sine theta now? Sine theta is x into what is cos theta in terms of sine theta? Because if you can convert cos theta into sine theta, then you can put the value for sine theta, which is equal to x. Is that clear? So what is cos theta in terms of sine theta? It is root over 1 minus sine square theta. Then what do we write? Plus c. Or I1 is equal to, this is your 1/4 sine inverse x minus 1/4 x root over, this is your 1 minus x square plus c. That is the value for sine theta is x. Okay, so this is the value for I1, but this is not the answer, but the answer is the value for I. So let us put this value for I1 in I1. So what is I actually? Since I is equal to, this is x square by 2 sine inverse x, then what is here? Minus I1. So let us put the value for I1 now. Or now this is I is equal to x square by 2 sine inverse x. Now minus I1 is there. Put the value for I1, you have to change the sign also. Minus 1/4 sine inverse x. Okay, minus to minus, plus 1/4 x root over 1 minus x square. Then what do we write? Plus c. So this is the final answer. So I think you have understood it. So this question is very, very important. You can mark it, because this type of question you may get in your HS examination. Okay, so this question is very, very important. So I hope you have understood it. You can copy it. So this much is for today. आज हामीले नयाँ च्याप्टर गर्यो, that is integration by parts, that is exercise 7 from the book Higher Mathematics for Class 12 by SND. त जति पनि प्रब्लम्सहरु गरेका छौं, जति पनि मैले होमवर्क दिएको छु सबै नै गर्नु, होमवर्कहरु गर्नु, अनि तिमीले यो जति पनि प्रब्लम्सहरु गरेका छौ यो सबै घरमा रिभिजन गर्नु. You do your homework, and in the next online class we'll do more problems on this integration by parts. So this much is for today.